Cape Canaveral on an October morning in 1997, and whatever left this pad that day was never going to come back. Either side stood two solid boosters, each as tall as a 12-story building, and once lit they could not be stopped. They would burn until the fuel ran out, and no one on Earth could shorten that. A million kilograms of machine and fuel standing in the dark, perfectly still. At 8:43 that morning, the whole of it went up. Under the nose cone rode 5.5 tons of machine, most of which was propellant it would not touch for another 7 years. The spacecraft itself accounted for barely a third of that weight. Bolted to its flank was a second machine altogether, 300 kilograms, folded shut and built from the start to be thrown away. Saturn has hundreds of moons, and all of them are bare rock and ice except one. Titan alone has an atmosphere and weather and liquid on its surface. A day into the flight, a radio signal still crossed to it in under a second, and it would never again be that close to home. And then, instead of climbing away towards Saturn, the spacecraft turned inward, towards the Sun. The rocket beneath it was the most powerful available. It gave everything it had, and it was still nowhere near enough to reach Saturn. Nobody at the Jet Propulsion Laboratory was surprised. They had known it since long before the spacecraft was built. No rocket then standing anywhere on Earth could throw something this heavy that far. So the speed it still needed would have to be found somewhere else. Their answer was to borrow it. Fly close enough to a planet and a spacecraft comes away, carrying a little of that planet's motion. 4 planets, 4 times. They went to Venus first. In April of 1998, it passed 200 kilometers above the cloud tops, closer to Venus than the space station is to us. The spacecraft came away from that encounter faster than it had arrived, and pointing somewhere entirely new. A planet standing still would give nothing back, but no planet stands still, and what the spacecraft takes is a share of that motion. The planet slowed by an amount too small ever to measure, and the spacecraft gained an enormous one. 7 kilometers a second out of a single pass, and it was still not enough. Then nothing happened for a long time. The spacecraft coasted, and behind it the Sun grew steadily smaller. 14 months later it came back to Venus and took a second share of the same motion. And in the summer of 1999, it came home. Not for a last look at us, and not to say goodbye. It had come back to take speed from the Earth as well. It did not slow, and it did not stay, and that was the last time anything we have ever built came so close to home on its way out. That pass was the one that did it. After Earth, the spacecraft finally carried enough speed to reach Saturn. One planet remained at the very end of the year 2000, and this time the spacecraft kept its distance, 10 million kilometers, 68 Jupiters away. Too far out to help very much, and it gave the smallest gain of the four. The climb was finished. From there, all the spacecraft had to do was wait. And waiting is most of what happened next. There was no battery aboard. Cassini ran directly off 3 plutonium generators, and whatever they made in a given second was all it had to spend. 800 watts at launch, and by the time it reached Saturn, 750. Fading exactly on schedule. 2,400 days of it. Seven years out, Saturn. The rings were never a sheet. They stand about 10 meters thick, and yet they reach further across than the distance between the Earth and the Moon. Nor are they solid. They are countless separate pieces of ice, from specks of dust up to boulders, each one going round on an orbit of its own. Gathered together, the whole system would weigh less than one small moon. Cassini crossed the ring plane through a gap between two of them, travelling at more than 20 kilometers a second, with nothing to spare if it met anything solid. It turned its main dish forward and flew behind it, using the antenna as a shield against the dust. Then it lit its engine. One burn, 96 minutes long, and no second chance at it. Had the engine failed, the spacecraft would simply have flown past Saturn and been lost, after 7 years of travelling. Earth would not have known for over an hour. It worked. Saturn had it. On Christmas Day, Cassini let the probe go. A push about as hard as a person walking, and a slow spin to hold it pointing the right way. Then 20 days of nothing at all, no power, no contact, and no way to steer or stop. A machine falling towards a moon with everything switched off, waiting on a clock. It woke itself a few hours before arrival. Huygens met the top of the atmosphere at 6 kilometers a second, and the air began taking that speed away almost at once. Everything it had crossed 1 billion kilometers to do, it now had 2.5 hours in which to do. The angle had to be exact. Too steep and it would burn, too shallow, and it would skip off the atmosphere into space. It held its nose within a few degrees of straight ahead the whole way in, and that is what kept it alive. 3 minutes later, almost all of that speed was gone, taken by the air and carried away as heat. A mortar fired, and a small pilot parachute snapped open while the probe was still falling faster than the speed of sound. Then the big canopy above it. The heat shield fell away beneath it, and for the first time since launch the probe could see. High above all of it, one spacecraft held its dish on a point beneath the haze. Nothing else anywhere was listening. None of this was gentle. It swung and it tilted, and it turned 3 full times for every kilometer that it fell. Then, 10 minutes down, it began spinning the other way. Nobody has ever worked out why, and 20 years on it is still an open question. And while it fell, something was going wrong. A single line was missing from the orbiter's instructions, the line that would have switched on its second receiver. The probe was transmitting on 2 channels, and only one of them was being heard, so half of everything it saw went nowhere at all. Most of the other measurements went the same way, and nobody on the ground knew it was happening. Just a bare tone, like a telephone left off the hook. They found out afterwards, going through the data at a desk in Germany. They had expected the haze to break about 50 kilometers up. It did not. It hardly thinned at all the whole way down. It cleared eventually, low down, with the greater part of the fall already behind it. And at some moment nobody could afterwards point to, the ground stopped being a rumour and became a place. By then, it had been falling for more than 2 hours. There was a coastline, pale hills cut by branching channels running down into dark, flat ground, riverbeds dry on the day it photographed them. Nobody can tell you what liquid cut them. We have the shape of it and not the chemistry, methane or ethane or both together. Something falls out of that sky, runs downhill, cuts those channels and collects in the low ground. Earth is the only other place we know that happens. These are the real photographs, not a reconstruction, the frames the camera actually sent back, and the only pictures of that surface anyone will have for years. It came down at walking pace, dug a small hole, bounced out of it, slid a little way, and stopped. Outside, 179 below zero. The air out there is 4 times as dense as ours. You could very nearly lean on it. Hardly any sunlight reaches that far down, and what does has come through 200 kilometers of haze to get there. And then, after all of it, the ground turned out to be damp. Methane rose off the soil where the warm probe was sitting. It had been built to last 150 minutes. About an hour after landing, the signal stopped, and not because the probe had stopped. Cassini, the only thing listening, went below the horizon. On Earth, radio telescopes could still hear its carrier tone for another 3 hours. Then the observing time ran out and everyone went home. Nobody knows when it finally stopped.